You ever see something that looks like pure magic, but it's super simple? Well, today we're diving into exactly that. We're looking at a beautiful experiment that seems to completely defy logic, but really, it's just showing us a fundamental force of nature. Let's get into the walking water rainbow. So, right off the bat, I've got a question for you. Can water actually defy gravity? I mean, can it really walk? Can it travel upwards all on its own? It sounds totally impossible, right? But that's exactly what this experiment seems to do. And the experiment that brings this question to life is called the walking water rainbow. The setup couldn't be simpler, but the result? It's absolutely stunning. You set it up, walk away, and overnight, the colored water literally seems to walk along these little paper towel bridges, moving from full cups into empty ones and creating a full-blown rainbow. Now, I know, it totally looks like a magic trick. But here's the thing, it's not. It's pure science. What we're seeing is a fundamental law of physics doing its thing, a law that's at work all around us, all the time. This experiment just makes it visible in a really, really colorful way. Okay, so to really get our heads around the science, we gotta break down the setup first. Let's deconstruct how to build this liquid bridge, because that's the first step to unlocking the how and the why behind this whole process. And you're gonna love this, the stuff you need. You've probably got it all in your kitchen right now. All it takes is 6 clear cups, some plain old water, the 3 primary food colors, so that's red, blue, and yellow, and a couple of paper towels. That's it. Simple, right? And the setup itself is just as easy. So you just line up your 6 cups in a row, and then you fill every other one with water. Next, you drop in the colors. Red in the first one, yellow in the third, and blue in the fifth. Finally, you take some paper towels, fold them into strips, and make these little bridges that connect each cup to its neighbor. One end in the water, the other in the empty cup, all the way down the line. All right, once everything's in place, that's when the real show starts. This isn't an instant chemical reaction or anything. It's more like a slow, beautiful parade of color. But this isn't an instant thing. You gotta be a little patient to see the magic unfold. You'll see it happen in a few stages. Believe it or not, in just about 10 minutes, you can already see the water starting to creep up the paper towels. Wait a few hours, and you'll notice the empty cups are actually starting to fill up with colored water. And then, when you check it the next morning, boom, the water levels have all evened out, and you've got a perfect liquid rainbow. So, where does the rainbow part come from? Well, that all happens inside those once empty cups. The red water from one side and the yellow from the other, they meet right in the middle. And what do you get? Orange. Same thing happens with the yellow and blue. They mix and make green. And if you use a 7th cup, the blue and red would eventually mix to give you purple, completing the whole spectrum. Pretty cool, huh? Okay, so we've seen what happens. Now for the really cool part. Why does it happen? How in the world does that water climb up and over? The source material calls the process a sneaky spy, and honestly, that's a perfect way to think about it. So let's uncover the secret. The official scientific name for this incredible walking water trick is capillary action. And what is that? It's simply the ability of a liquid to flow through really narrow spaces, even if it has to fight against forces like gravity to do it. This right here is the engine that's driving our entire experiment. And to really wrap your head around it, the source material has this amazing way of putting it. It says to imagine capillary action working like a chain of friends holding hands. One water molecule gets pulled up, and because they're all sticking together, it just pulls the next one along with it, and so on and so on. So, what's behind this hand-holding? It's all about 2 key forces, adhesion and cohesion. Think of it this way. Adhesion is the water molecules being sticky and grabbing onto the paper towel fibers. Cohesion is the water molecules being sticky and grabbing onto each other. So you get this amazing teamwork. The water grabs the paper, then pulls all its buddies along for the ride, right up and over, completely defying gravity. Now, you might be sitting there thinking, okay, that's a neat party trick, but here's the kicker. This isn't just a trick. Capillary action is a fundamental force of nature, and it's happening all around you every single day. Let's look at why this is so much bigger than just our 6 little cups. Seriously, this force is at work everywhere, and in some pretty incredible ways. I mean, how do you think a giant redwood gets water from its roots all the way up to its tippy-top leaves? Yep, capillary action.
It's the entire reason paper towels and sponges are so good at soaking things up. It's even the secret behind how a fountain pen works, pulling ink down to the tip, and how a candle wick keeps drawing wax up into the flame. It is truly everywhere. So yeah, the walking water rainbow, it's not really magic after all. It's just a beautiful, colorful way to see a powerful, hidden force of science in action. And that just leaves me wondering, what other bits of magic in our everyday lives are really just amazing science we haven't taken a closer look at yet?